from linear algebra I have taken one problem. In this problem we are going to find eigenvalues of the given matrix. So first of all, before finding eigenvalues, I will state some result. So first I am recalling some basic result which we are going to use in this problem. So first one is, if each row or column of matrix sum to A, then A will be eigenvalue. What I mean, if you are adding a row of the matrix, if it is coming for some number, then that number will be your eigenvalue. If suppose I am adding column, if I am adding first column, if after adding I will get some number 5, then my 5 will be the eigenvalue. So see here, in this case, if I adding this will get 1. If I will add 1, if I add this row I will get 1. If I add this row I will get 1. If I will add this row I will get again 1, and same the way if I am adding this I will get 1. So that means my 1 will be the eigenvalue. Okay, so I will come to that point later. Okay, so my second result will be trace of A is nothing but sum of eigenvalue. Right, using these two statement I will solve this problem. So as I was telling, the sum of this first row is 1. Okay, this is going to be 1. In the same way, for each row we can define this is going to be 1. So like that, each row is summing 1. So that means 1 is lambda equal to 1 is my eigenvalue. Okay, if lambda is 1 is my eigenvalue, and if we see the behavior of this matrix, so this is nothing but real symmetric matrices. So that means real symmetric matrices have eigenvalue real. So जो complex वाला part है that will going to be vanished. So this option is not possible, right? If 1 is my eigenvalue, okay, and we know the real symmetric matrices have eigenvalue real. So the complex part which we are getting in eigenvalue, that is not possible. So I will discard this option. Okay, and again I am observing. So here my eigenvalue is 3 and minus 3. So but we have at least one eigenvalue should be 1. So this is also not possible. So now we left with this. Okay, so see here, trace of A is 0. So at that time my eigenvalue will be in alternative. So that means my eigenvalue, see 1 is my eigenvalue. So 1 minus 1 plus 1 minus 1 plus 1 minus 1. Okay, so we should have 6 eigenvalue. Okay, so so this is my eigenvalue, right? So this is my eigenvalue. So from here I can conclude this is 0. So my eigenvalue will be 1 and minus 1. So the option will be D option is the correct one. So from here we can conclude the option D is correct. So while approaching the problem, you should know which result I am going to apply. Okay, so while observing this and observe the this given options, then you have to eliminate the given options by solving this problem, and we have to use the result whatever we know about the matrix, that particular matrices, so we can we can conclude it. So thank you for today. I will catch you later in the next session, and that will again I will come with some interesting problem that might be helpful for your exam.